right so far? We start talking about, okay, vectors, and then we talked about surfaces in the space. So recall that. If we have 2 points, P1 and P2 in the space, for 2 points, like P1 with coordinates x1, y1, and z1, and the second point with coordinates x2, y2, z2. These 2 points are in the space, three-dimensional space. Suppose this is San Jose, P1, and this is San Francisco, P2. We start from P1, we start from San Jose, and we go to San Francisco, P2. The initial point, the terminal point. Initial point and terminal point. Well, you're actually constructing a vector. So when we have a vector, we can actually write the components of the vector. So this vector can be written as P1, P2 with a bar on top of it. Sometimes we use an arrow, some other times we just use a bar. So this is a vector starting from P1 and stopping at P2. The components of this vector can be written as x2 minus x1, y2 minus y1, and z2 minus z1. So these are the components of this vector. Here you have coordinates. So these are the coordinates of a point, and these are the components of the vector. Perfect. We said that, hey, now that we construct a vector, we can actually find the length or the norm or the magnitude of that vector. For any vector, we can find its length, norm, or magnitude. It's defined this way. The absolute value of P1, P2, this is a vector that we're constructing, is equal to, this is the square root of, we take each of these components and we square them. So here we have x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And remember that this is the distance between 2 points, or the magnitude, or the length, or the norm of the vector. Distance between 2 points, or the length of a vector. All equivalent to each other. They're referring to the exact same. So we use the definition of the distance to write equation of sphere. A sphere with center, and what's the center? HKL, and radius R. Can be written this way: x minus h squared plus y minus k squared plus z minus L squared equals to R squared. So we have a sphere in the space centered at HKL at this point, and the radius is equal to R. We derive this formula from the definition of distance and the definition of sphere. So let us write down one example. Our goal is to identify this equation. Example says, identify the following. What is given to us? We have x squared plus y squared plus z squared plus 4x. Then we have another linear term, minus 6y. The next linear term is 2z. And then we have a constant z, 6, equal to 0. Okay, perfect. What do we have here? X squared plus y squared plus z squared, some quadratic terms, some linear terms, and a constant, it is equal to 0. We have an equation and we need to identify this equation. What does this equation represent in the space? Okay, perfect. So what are we going to use? We're going to use what we learned in elementary algebra. Remember that if you have, for example, a squared plus 2ab plus b squared, you can write this expanded form into compact or short form a plus b squared. Perfect. What I'm going to do, I'm going to group x terms, y terms, z terms separately and try to follow the formula. I'm going to use different colors. So here I have x squared, x term, another x term, 4x. Then I'm going to group y terms, y squared minus 6y. Then I'm going to group z terms. So for z terms, let's use blue. Here we have z squared plus 2z, and you have a constant. So let's write down the constant here, plus 6 equal to 0. Our next step is to use the method of completing the square. Here you have two x terms. You get x squared plus 4x. And if you have your constant, you can follow the formula and write it in compact form. Well, 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 and subtract 4. So it means that I'm adding 4 to the other side as well. Now for y's. I have y squared minus 6y. Negative 6 divided by 2, negative 3. Negative 3 squared is 9. So I'm adding and subtracting 9 to both sides. This is your question. How about z squared plus 2z? I have 2 divided by 2, 1. 1 squared is 1. So I'm adding and subtracting 1, adding 1 and subtracting 1. I can bring subtraction to the other side. So this is my 1. Okay. Well, we group these three together and we have x plus 2 squared. We group these three together. We have y minus 3 squared. we group these three terms together to write it in nice compact form. Z plus 1 squared, and we can bring the constant to the other side. Equal to 4 plus 3 plus 1 is equal to 8. So I haven't done that much. I just did the algebra, applied the formula that I learned before. Now, what is this equation? So this is from algebra. What is this equation? Equation of the sphere that you learned before. Sphere is written as x minus h squared plus y minus k squared plus z minus l squared equals to r squared. This is the equation of a sphere centered at h, k, l with a radius r. Compare these two equations, term by term. X minus h is equal to 2, so h is minus 2. K is equal to 3. L is equal to negative 1. R squared is equal to 8. So R is square root of 8, or R is equal to 2 square root of 2. This is your radius. So what is this? This is a sphere with center, -2, 3, and -1, and radius is 2 square root of 2. You identify this equation in this. Let us take a look at the graph. If we graph x squared plus y squared plus z squared plus 4x minus 6y plus 2z equal to 6, this is the graph that we have. We have a sphere with center. As you can see, the center is not at the origin. Take a look at the board. As you can see, your x on horizontal axis is negative, your y is positive, and your z is negative. So, as you can see, your x coordinate is on negative part, your y coordinate is in positive part, and z is negative. So that's why you see a shift, a little bit of shift downward. Another example for you. I want to identify this region in the space. Identify the following region. So they have x squared plus y squared plus z squared. It is sandwiched between 1 and 4. Another one is x squared plus y squared plus z squared is sandwiched between 1 and 4, and it has additional condition that z is less than or equals to 0 as well. Sorry. Okay, perfect. So what is this inequality? This inequality says if you have a point in the space and if you raise its coordinates to the second power and add them all together, that sum must be in between 1 and 3 inclusive. So the sum of the square of the coordinates is in between 1 and 4. Well, each of these separately. Here you have 1 less than equals to x squared plus y squared plus z squared. If you forget about the inequality, here you get a unit sphere. Unit sphere, it means that the radius is 1 and it is centered at the origin. Okay, perfect. How do we graph this? Here you have your x-axis, your y-axis, and your z-axis. Unit sphere. 1, 1, 1, and here you have your sphere. Okay, in 3D. And this is one. Look at the other part. Here you have an inequality saying that, well, your x squared plus y squared plus z squared must be less than equals to 4. If you look at this as the sphere, as a boundary, you get x squared plus y squared plus z squared equals to 4, which is a sphere centered at the origin with radius 2. Radius is equal to, means that you have a larger sphere. Beautiful sphere, but still good. So here we have our sphere with radius 2, and here we go. Okay. But our example says if you take the coordinates of those points, square each coordinate, add them together, it must be greater than or equal to 1 and less than equals to 4. It means that you're looking at all these points in between these two spheres. These are all the points, x squared plus y squared plus z squared, bounded between 1 and 4 inclusive. So you have to just erase the rest of it, and then this is the answer to this question. Well, now take a look at the second part. The second part says, hey, those points, if you take the coordinates, square them, add them together, it must be between 1 and 4, and you have additional condition. Your z cannot be positive. Your z is less than or equal to 0. It means that we have to ignore the upper half, and the answer is only the lower half. So here you have your x, y, and z axis, and then by graphing this was your inner sphere with radius 1, and then this is the larger sphere with radius 2. So we're looking at these ones. Z is negative. So just the middle region in between these two spheres. X squared plus y squared plus z squared is bounded between 1 and 4, and z is also less than equal to 0. So remember that these are regions or surfaces in this space. So the projection of sphere, the projection of sphere, like x squared plus y squared plus z squared equals to 1. Suppose you have a unit sphere on xy plane is a unit circle. X squared plus y squared equals to 1. On xy plane, z is equal to 0 because on xy plane, z is equal to 0. So what are we doing? We are having a sphere in the space x, y, and z. This is your sphere. Unit sphere means that the radius is equal to 1. So this is an object. This is like a ball. So this is just x squared plus y squared equal to 1. If the question says, well, what if I write it this way? The question says, hey, what if I write it as x squared plus y squared plus z squared less than equals to 1? Is it still a ball or is it a solid ball? This is a solid ball. Means that we have to include all of these points inside the ball as well. So here you have x-axis, here you have your y-axis, here you have your z-axis, and this is the same graph. The boundary is exactly the same. There's no difference between the boundaries. 1, 1, and here you have this guy here. Here you have this guy here. And now you shade everything. You shade all the points inside the ball as well. So here you have a solid sphere or solid. So if you project this in xy plane, the answer is not just a circle. It's a disk. The projection of the solid sphere on xy plane is a solid circle or a disk. So the projection, it means that if I just dense and project this on the xy plane, it's going to be like this. Xy plane, the projection is all points on and inside the circle. But if I project this one in xy plane, the answer is just a circle, the boundary. We do not include the points inside the circle. That's just a circle. Okay, let's talk about vectors.